Hello, students. So next topic in haloalkanes and haloarenes is classification of dihaloalkanes containing two similar halogen atoms. That is, there are two halogen atoms present in the molecule, and both the halogen atoms are same. That is, two chlorine atoms, two bromine atoms, like this. How do we classify them? They are classified into three categories. One is vicinal or Vic dihalides. Vicinal word comes from vicinity. Vicinity means neighborhood. So vicinal dihalides are those in which halogen atoms are attached to adjacent carbon atoms, right? And their general common name is alkylene dihalides or alkylene halides. In general, their common names are alkylene dihalides or alkylene halides. If we write halide, it's understood it is dihalide, right? For example, CH2Cl, CH2Cl. There are two carbon atoms, ethane. Ethane becomes ethylene. So common name will be ethylene dichloride or ethylene chloride. IUPAC name will be 1,2-dichloroethane. Let us say the compound is three carbon atoms. It becomes common name is propylene dibromide or propylene bromide. IUPAC name will be 1,2-dibromopropane. Butylene dibromide. But the problem is this is also butylene dibromide or butylene bromide. Both have same common name. Remember, both have same common name. Both fall under the category vicinal dihalides. Their common name are same, that is butylene dihalide. Therefore, common name butylene dihalide, dichloride or dibromide is not used for them, but yes, they belong to vicinal dihalide. Definitely, their IUPAC names are different. This is 1,2-dibromobutane. This is 2,3-dibromobutane, right? So no common name for them, but they belong to vicinal dihalides. Second category, geminal or gem dihalides. Geminal or gem dihalides. These are the compounds in which both the halogen atoms are attached to the same carbon atom. Same carbon atom. And they should have minimum two carbon atoms, because if there is only one carbon atom, two halogen atoms are bound to be attached to the same carbon atom. So that is not considered in that category, right? Although that is geminal dihalide, but is not classified under that category. There should be minimum two carbon atoms. Their general common name. They are called alkylidene dihalides or alkylidene halides. For example, CHCl2, CH3, two carbon atoms, ethane. Ethane becomes ethylidene. So common name ethylidene dichloride or ethylidene chloride. IUPAC will be 1,1-dichloroethane. This one. Three carbon atoms, propylidene dichloride, IUPAC name 1,1-dichloropropane. This also has the same common name, three carbon atoms. So both have the same common name, propylidene dichloride, propylidene dichloride. IUPAC names are different. 1,1-dichloropropane, 2,2-dichloropropane. Now coming to their common names. Both have the same common name. One way we do not use the common name because both have the same common name. Second possibility is if we can somehow protect these common names by using prefixes, then common name can be used. So yes, for this I can use the prefix normal, which I'll tell you later in this video. This is normal propylidene dichloride. This is iso or secondary propylidene dichloride. How do we use normal, secondary, iso prefix? That I'll tell you later in this very video. Third category. Third category is called polymethylene dihalides. Polymethylene dihalides or polymethylene halides. In this category, there should be minimum 3 carbon atoms. All the carbon atoms should be arranged in a straight chain. There shouldn't be any branch. First and last carbon carry 1 halogen atom each, right? So I'll repeat, minimum 3 carbon atoms, all arranged in a straight chain. First and last carbon atom carry 1 halogen atom each. They are called polymethylene dihalides or polymethylene halide. For example, first of all, poly. Poly means many. Methylene means CH2. CH2 group is called methylene group. In this structure, you can see there are 3 methylene groups. Poly is replaced by tri. Common name becomes trimethylene dichloride or trimethylene chloride. IUPAC will be very simple, 1,3-dichloropropane. There are 5 methylene groups in this compound. The common name will be very simple. For 5, we'll use penta. Common name is pentamethylene dichloride or pentamethylene chloride. IUPAC will be 1,5-dichloropentane. Let us say I'm given the common name, and the common name is tetramethylene bromide. Tetramethylene. 4 carbon atoms in a straight chain. Bromide means bromine. Now, if you say that bromide means only one bromine, then let us try to satisfy the valency. If I satisfy the valency, then last carbon atom is not methylene, it is CH3, that is methyl. And the common name I said tetramethylene. There should be 4 CH2s. If I write 4 CH2s, then the valency of last carbon is not satisfied. It means this carbon is also attached to the same halogen atom. So this is the structure for tetramethylene bromide or tetramethylene dibromide, and IUPAC will be 1,4-dibromopropane. Now coming to general nomenclature of alkyl and aryl halides. Now in general, as I told you earlier, in general, haloalkanes is the IUPAC name, alkyl halides is common name. Similarly, for aromatic halides, common name is aryl halides and IUPAC name will be haloarenes. Now we'll take up many examples and there is a lot to learn in this nomenclature. As I said, common name alkyl halide. There will be 2 words. Methyl chloride. That's the common name. IUPAC name is haloalkane. That is 1 word. IUPAC will be chloromethane. Right? I'm not writing just to save time. Next. Common name ethyl bromide, IUPAC bromoethane. Now these two compounds both have 3 carbon atoms, both have 1 iodine atom. It means both have the same common name. Both are propyl iodide, and this one is also propyl iodide. Now, remember, no two siblings in the same family, no two children in the same family have the same nickname, that is common name, like Papu, Bittu and all. No two children in the same family have same official name, that is IUPAC name. As far as their IUPAC names are concerned, their IUPAC names are different because this is 1 iodopropane, this is 2 iodopropane. But propyl iodide is the common name. Even common name should not be same. If we can somehow protect these common names, then we use, otherwise these common names will not be used. Now, this one is normal propyl iodide. This is secondary propyl iodide, or also called isopropyl iodide. I'll tell you about how to use these prefixes. Overall, I'll tell you about 5 prefixes: normal, iso, secondary, tertiary, and neo. How do we use these prefixes? These prefixes we'll be using in the entire organic chemistry. First, normal. See, normal, one thing more, these prefixes will be written in small letters. They are not written in, they do not start with a capital letter. And preferably, I'm using the word preferably, they are used in common nomenclature. They should not be used in IUPAC nomenclature. Although there's a trend, they are being used in IUPAC nomenclature also, which should be avoided. So when do we use the prefix normal? We can write the complete word normal, or we can simply write N. See, this prefix is used when there are minimum 3 carbon atoms. They can be more than 3. All of them are attached in a straight chain. And if there is a functional group at all, that functional group should be present on one of the 2 terminal carbon atoms, not both. I'll repeat. When do we use the prefix normal? Minimum 3 carbon atoms, all arranged in a straight chain, no branch. If there is a functional group at all, that should be present on one of the 2 terminal carbon atoms, not both. For example, if I say this compound, just now I consider this one, 3 carbon atoms in a straight chain, normal propyl. Iodine on one of the terminals, iodide. The common name is normal propyl iodide. I'm just telling you how to use the prefix normal. Don't think I've taken the example of alcohol. 4 carbon atoms in a straight chain, normal butyl. Functional group is OH, alcohol. The common name will be normal butyl alcohol. Right? If I say 6 carbon atoms in a straight chain, but no functional group, then common name will be N-hexane, normal hexane. Remember, normal hexane is common name. Hexane is IUPAC name. Right? I told you functional group may or may not be present. If present, it should be on one of the 2 terminal carbon atoms, not both. If I say NH2 group here, then common name will be normal hexylamine. Second prefix, secondary and tertiary. Secondary and tertiary prefix, I'll tell you a little later. In the example which I considered a little while ago, if halogen is attached to a secondary carbon atom, we'll use the prefix secondary. Then it was like this. secondary propyl iodide because iodine is attached to a secondary carbon atom. I told you this is also called isopropyl iodide. When do we use the prefix iso? See, prefix iso is used when three carbon atoms like this are in any case present in the molecule. If there are more than three carbon atoms, then remaining carbon atoms should be bonded to this carbon atom in a straight chain. Leftover carbon atoms, if any. If there are more than three, let us say there are total 10 carbon atoms. So remaining 7 carbon atoms will be bonded to this in a straight chain. And if there is a functional group, if any, if there is a functional group, that should be attached to the last carbon atom of the extended chain. Extended chain, right? I use the common name normal propyl iodide. Let me justify. Sorry, isopropyl iodide. Let me justify this common name. Iso. The moment I see iso, I have to use this three carbon atoms. Propyl means three carbon atoms. I have used all the three carbon atoms. There's no more carbon left to be attached here. Last word is iodide. Iodine attached to the last carbon atom. Last carbon atom is this one. This is what? This is nothing but these are same compounds, represent the same. So this is isopropyl iodide. I'll take more examples. If I say isopentane, if you remember, you studied about isomers of pentane in 10th standard. Isopentane. Iso, three carbon atoms. Pentane means two more carbon atoms attached to this carbon in a straight chain. And there's no functional group. This is the structure of isopentane. If I say isohexyl alcohol, this is iso. Hexyl means three more carbon atoms. Alcohol means OH. I'll attach OH to the last carbon of extended chain. OH will be attached here. Do not attach OH group to any other carbon atom, right? That will not be iso, right? So I've told you how to use the prefix normal and iso. Secondary and tertiary I'll take up in detail. Now we take up an exercise in which we'll write isomers. Let us say we write isomers with the formula C4H9Cl. How do we write isomers without wasting time? Write all the carbon atoms in a straight chain, halogen on one terminal. Repeat the chain and shift halogen. If I further repeat and shift halogen, if I further repeat the same chain and shift halogen, it will be same as this one. Look here. Same chain, further shifting means these are same. Now, when repetition starts, cut the chain by one carbon. Now, chain of three. We are left with one carbon. Leftover carbon will not be attached to terminal carbon atoms. It should not be attached to this or this carbon because that will again become a straight chain of four carbon atoms. Attach this leftover carbon atom to the middle carbon. Use this arrangement of carbon atoms and keep on shifting the position of halogen. This. If I attach anywhere else, it will be repetition, right? We cannot further reduce the chain length, because if I further reduce the chain length to 2 carbon atoms, I said remaining leftover carbon atoms will not be bonded to terminals. Both are terminals now. Now, their common names are same. All these are 4 isomers. Their common names are same. They are butyl chlorides. Now we'll use prefixes for them. First isomer is normal. I told you about normal. Very easy. This is normal butyl chloride. This is isobutyl chloride. I told you about iso also. This is isobutyl chloride. This is secondary butyl chloride because halogen is bonded to a secondary carbon atom. This is tertiary butyl chloride because chlorine is bonded to a tertiary carbon atom. So all the 4 have different prefixes. So all the 4 have proper common names. Their IUPAC names will be 1-chloroputane, 2-chloroputane, 1-chloro-2-methyl propane, and this will be 2-chloro-2-methyl propane. We take up one more exercise. C5H11Br isomers. See, now it'll be very fast. 5 carbon atoms in a straight chain, bromine, repeat and shift, repeat and shift. If we further repeat and further shift, then isomer will be repeated. Now I'll cut the chain by 1 carbon atom, chain of 4. 5th carbon will not be bonded to terminals. Now attach here. Use this arrangement of carbon atoms repeatedly and keep on shifting position of halogen, bromine. Same arrangement, bromine shifted. Same arrangement, bromine is shifted. Same arrangement, you can attach bromine to this or this carbon atom, that will be one and the same thing. Further cut the chain by 1 carbon atom. Now chain of 3 carbon atoms. I'm left with 2 carbon atoms. Remaining 2 carbon atoms will not be bonded to terminals. I can bond them to middle carbon atom. But this is not the proper arrangement because this gives a chain of 4. We have already considered a chain of 4 carbon atoms. It should be a chain of 3 carbon atoms. So this is the arrangement. Now you can attach bromine to any one of these 4 carbon atoms. That will be one and the same thing. Bromine. All of them have the same common name, that is pentyl bromide. Now prefixes. This is normal pentyl bromide. When you think of isomers, there will be only one normal, not more than one normal. Similarly, there will be only one iso, not more than one iso. And the iso in this case is this one, 4th. This is secondary. This is secondary. This is also secondary. Since there are more than one secondary, common name with secondary prefix will not be used for any one of them. No common name, no common name, no common name. So remember, this is not secondary pentyl bromide. This is one of the secondary pentyl bromides. I hope it's clear. If I say this is secondary pentyl bromide or this is secondary pentyl bromide, it means this is the only secondary pentyl bromide. No, there are more than one secondary pentyl bromides. Therefore, I'll say this is one of the secondary pentyl bromide. No common name used for them. This one is tertiary. There's only one tertiary. This one is At the most, I can say primary, but I cannot use primary prefix in this case. Why? Because normal is also primary, iso is also primary, this last example is also primary. Therefore, no common name for even second last isomer. This one is neo. This is neopentyl bromide. Now, from here, we conclude about secondary and tertiary. So remember, secondary and tertiary prefixes will be used only when there is only one isomer which is secondary, or only one isomer which is tertiary. I'll repeat, if there's only one isomer which is secondary or tertiary, then prefixes secondary and tertiary will be used. Otherwise, they will not be used. When I consider isomers with C4 before this, I use the prefix secondary because there was only one secondary. In this case, I'm not using secondary prefix because there are more than one secondary. Similarly, so far I'm using tertiary because there's only one tertiary. But if there are more than 5 carbon atoms, then there will be more than one tertiary isomers. In that case, tertiary prefix will not be used. Now I'm left with only one prefix, that is neo. IUPAC will be easy. IUPAC you can do. Let me tell you. 1 bromopentane, 2 bromopentane, 3 bromopentane. This one will be 1 bromo, 3 methyl butane, 2 bromo, 3 methyl butane. Now the direction changes. 2 bromo, 2 methyl butane, 1 bromo, 2 methyl butane, and this one 1 bromo, 2 dimethyl propane. Now, where do we use the prefix neo? It is similar to iso. Similar to iso, with the only difference that in case of iso, it was this compulsory. Now, in case of neo, this is compulsory, rest is same. So this arrangement of 5 carbon atoms, which looks like a star, is compulsory, it's a must. If there are more than 5 carbon atoms, let us say there are total 7 carbon atoms. So remaining 2 will be attached to any one of them, of course. Let us say to this one. And if there is a functional group, that should be attached to the last carbon of the extended chain. If there's no functional group, then it's okay. For example, common name neopentyl bromide. We use this common name. Neo means this is compulsory. Pentyl means 5. I've used all the 5 carbon atoms. Bromide, bromine. If I say neoheptyl amine, neoheptyl amine means neo 5 carbon atoms. Heptyl means 2 more carbon atoms. 1, 2. Amine means NH2. Last carbon of the extended chain carries NH2. So this is the structure of neoheptylamine. Rules, apply rules, and you can write IUPAC name of this compound, right? So I told you about 5 prefixes. Now we'll take up some more examples of nomenclature in the next video, because this is going to be a lengthy video otherwise.